let's learn operators in C in this video. An operator in C is a symbol which lets you perform operations on operands. And if you look at the types of operators, you have arithmetical operators to do addition, subtraction, product, the quotient and the remainder. Relational operators which lets you perform the relation on two values. The logical operators, the exclamation refers to the not, the two ampersands will refer to the logical and the two pipe symbols refer to the logical or. And the order of operation of the logical operator is not and or. Bitwise operator, these bitwise operations happen on individual bits of a number. The bitwise and, bitwise or, the bitwise XOR, the left shift and the right shift. Assignment operator, the usual assignment operator and then the shorthand notation, the augmented assignment operator. The unary operator, which these operators will require only one operand. The incrementation, decrementation, which combines both the post and the pre. The size of operator, the logical not. This will be the address of operator, and this is a dereferencing operator to retrieve the contents of the memory that the pointer is pointing to. The ternary operator, as the name implies, requires three operands, and this is a equivalent of the if statement, the conditional statement. We can write a code involving selection statement using a ternary operator. And other special operators which include the comma, the member selection operators, the dot and the arrow, they are member selection operators when we work on structures and unions. Now this table shows you the precedence of operators from the highest to the least, and it's so important you understand the precedence in order to evaluate expressions. So based on this precedence, let's look at some examples. So I'm using the online C compiler to look at the demonstration for each of the operators, examples for each of the operators. So let's assume we have two variables. I'll declare the variables, say A and B, and probably initialize them also. Say let's say A is a 5 and B is a 3. And based on these two variables, let's try and perform the basic arithmetical operations. So I'll want to have the sum of these two values shown. I'll specify the format, and the subsequent display I'll want it in the next line, so I've included the slash in. So the sum is going to be obtained using a plus b, and then the rest of the arithmetical operators I'll have the difference of the two numbers to be, the operation will be a minus b, and then the product of the two operators, product of the two operands, which will be a asterisk b, and then the quotient after division, that will be obtained using the slash operation. So if I run this set of statements, so the values have been obtained for the different operations. Now if you look at the quotient, now 5/b is retrieving me a 1 because this is involving integer divided by an integer. Both a and b, numerator and denominator, are integers, so I'm getting the result also as an integer. If we had wanted the complete quotient along with the decimal values, then one thing I could have done is declared my a and b as float, or if you continue to have a and b as integers, then you probably will have to typecast one of the numerator or the denominator. So I'll have the typecasting happening like this. So a has been cast to a float and then divided by a integer. So when mixed mode expressions are involved, the result will be the higher order data type. So between integer and float is a higher order, so accordingly the format specifier I'll change to a %f. So when I run the code, I'll get the value along with the decimal values. Now the remainder operation, so that will again fetch me a numerical integer value. So I've changed the format specifier, and the operator to obtain the remainder is a mod, the percentage symbol. So when I run the code, I get the remainder 2. 5 divided by 3, the remainder is going to be a 2. Now both my numerator and the denominator are positive values, so the final answer is a positive value. Now if one of it was a negative value or both were negative, so when I have a to be a minus 5 and b to be a 3, when the remainder is calculated, now what you have to understand in C is that a shortcut method of remembering, you do your normal division, obtain the remainder, and then attach the sign of the numerator. So minus 5 mod 3 will result in a minus 2. Supposing the numerator was positive and the denominator was negative, the remainder will still be a positive value. Supposing both were negative, numerator and denominator were negative, the final answer is going to be a negative. That is, after doing your normal division and calculating the remainder, you attach the sign of the numerator, shortcut method of remembering. Now relational operator, one example here is shown, the less than. Supposing 12 less than 20 is displayed, it returns a 1. So in C, the result of a relational operation won't be shown as a Boolean value, it will be shown as a numerical value. 1 will refer to a true and 0 will refer to a false. Now supposing I really had wanted the output to be shown either as true or false, now what you could have done is, the result of this operation 12 lesser than 20, let's say we have a variable a already declared, we can use that variable to store the result of a, and then finally we'll print a string. So for showing a string, the format specifier is a s, and what this string has to display, it is dependent on a's value. So if a is a non-zero value, now here we are making use of what I already mentioned as a ternary operator. So ternary operator has a condition to be checked, and if the condition is true, what is to be done will be mentioned after the question mark. If the condition is false, what is to be done will be mentioned after the colon. So simply saying a is equivalent to saying if a is a non-zero value, as in it's a true value. So if the result of this is a non-zero value, that is a true value, then in the question mark part I will assign the string true, and in the colon part I will assign the string false. So now when I execute, 12 less than 20 is displayed as true. So that's what I said. The relational operation in C will not result in any Boolean value as true or false. It will return either a 1 or a 0. If you had wanted a true or a false to be displayed, then we can make use of the ternary operator like shown here. When we combine the relational and the logical operation, we must keep in mind the order of precedence. So just now I have shown not of minus 2 less than 4. So this should not be understood as minus 2 less than 4 evaluated first, which will result in a true, and not of true will be a false. So you won't get a answer false, you are getting an answer 1. That's because the unary operator, if you refer to the table, the unary operator has got a higher precedence. So this is first done as not of minus 2. So any non-zero value, whether positive or negative, any non-zero value is treated as true. So what is not of a true? It will be a false, and false is represented as a 0. So this is going to be next evaluated as 0 less than 4. 0 is obviously less than 4, therefore the answer came as true. So if you had wanted this operation, relational operation, to happen first, then obviously we must have had a parenthesis shown there. So now when you evaluate, you will get the answer to be a false. To look at one another example involving relational and logical, so I have relational logical shown here. Amongst the logical, the order of operation will be the not, followed by the and, followed by the or. So if you let's look at this step by step. So I'll have the expression redone here again. So let's have the 20 less than 5, the relational operations result. I'll replace that with the 20 less than 5 is false. That will be a 0. And then the 5 not equal to 9. 5 is not equal to 9, therefore it's a true. I've replaced it to the 1. And 4 greater than 2. So this is what I said. This is not to be treated as 4 greater than 2, because a unary operator has got a higher precedence than the relational operation. So this is going to be done as not of 4. So not of 4 is a true value, not of true is a false. So it will be treated as a 0 greater than 2. A 0 greater than true is false. So the whole thing is going to be replaced with a false, 0. Now between the and the or, and happens first. So false and true is a false. And finally false or false will be a false. So result of this expression is a false. The individual steps are like what I explained just now. Now to look at a few bitwise operations. I have A as 5 and B as 3. So what will the result of A bitwise and B be? So let's evaluate this and see. It is showing a result 1. Now how we are obtaining a 1 is, so to understand the bitwise AND, the given numerical value 5, you first represent that as a 8-bit binary notation. So 5 is a 101, but represent it as a 8-bit notation. The 3 also, which is a 011, I've written as a 8-bit notation. Now the AND is similar to your logical AND. When both the values are true, the final answer is going to be a true. Any one value is false. So 0 and 1 is going to be a 0. 1 and 0 is going to be a 0. So obviously all of these are going to be zeros. So any one value is false also, the final answer will be a false. Only when both the values are true, the answer will be a true. And this is obviously the binary notation for the decimal value 1. That is why we got the answer 5 bitwise AND resulted in a 1. So now A bitwise OR, that is a pipe symbol. We'll see what this results in. It results in a 7. Again, to understand this, the 8-bit notations of 5 and 3 are written. For a OR, any one value is true, the final answer will be a true. So 1 or 1 is a 1, 0 or 1 is a 1, 1 or 0 is a 1, and the rest of it are 0, because 0, both the inputs are 0, the final answer will be a 0. So 111 to the base 2 is 7 to the base 10. So 111 in binary is 7 in the decimal notation. Now the next operation, A XOR B, which is represented by the caret symbol. Now what this XOR operation does is, when it compares two bits, when there are odd number of ones, the final answer will be a 1. I'll just show you. So I'm executing this. The answer is a 6. To understand how, again the 8-bit notation of 5 and 3, the least significant bit, if you notice, there are 2 ones here. So that will be even number of ones. When there are even number of ones, the result will be a 0. When there are odd number of ones, so here there is only 1 1, the answer will be a 1. Odd number of 1, again it's a 1. And there are no ones, that is 0 ones, that is even number of ones, it will be a 0. So XOR will result in a output 1 when there are odd number of ones. So now 110 is the binary notation of the decimal number 6. Now to look at the left shift operator, that will be represented by the 2 less than symbols. So 5 left shift 3. Now how this is to be understood is, the binary notation of 5, when you write, the digits are to be shifted to the left B times. So B is a 3, so we shift the bits to the left 3 times, and when you execute, the result of 5 left shift operator 3 results in a 40. So this is the 8-bit notation of 5. The first time when I shift, all the digits you have to shift to the left. So when the remaining digits at the right are on shifting, you replace with the 0. So first time, this is one time shifting. The second time shifting again to the left, and the third time shifting again to the left. This is what I will have as a final binary notation. So this is nothing but 40 in decimal. 1, 2, 4, 8, 16, 32. So this is going to be a 32 plus a 8, which is nothing but your 40 in decimal notation. Similarly, the other operator, which will be right shift. So shift A to the right B times. So when I run the code, answer is a 0. Let's see how. So you just have to imagine you're shifting all the digits to the right. So first time when I shift, this 1 will be gone. The new digits at the left are going to be filled with a 0. Next time you shift again, the 1 has shifted to the right, and the remaining places subsequently shifted to the right. The third time when I shift, the 1 is gone, and finally that will end up in a 0. So binary notation for 0. Now let's look at the increment-decrement operators. Now where you have the post happening, the way you understand the post increment or decrement, the way this is understood is use and then change, and the pre is going to be understood as change and then use. So to have a understanding of this, let's say I am having a variable c which is declared with or initialized with a plus plus times a minus minus b. And also what we need to keep in mind, a post incrementation has a post operation, whether incrementation or decrementation, has a higher priority than pre. Now finally let's try and print the value of c. So when I run the code, the answer is a 10. So how you need to understand this is, at this part of the expression, a is used as a 5 and then it is incremented to a 6. Here b is reduced to a 2, decremented by 1. So it is reduced to a 2 and then used, changed and then used as 2. So 5 into 2 is a 10. So the thing about post and pre is, for a post it is use and then change, and for a pre it is change and then use. And the first thing that will happen is the post operation. As for instance, supposing instead of using a b, I've used the same a. So after this operation, let's try and see the value of a as well. I'm having the a's value shown. So when I run the code, okay, I have not included the new line escape sequence character. So the first value c is shown as a 25 and a's value shown as a 5. So how this is to be understood, at this point a is used as a 5 and then changed to a 6. Here the 6 is decremented as 5 first and then used. So it's a 5 into 5, 25, and the final value of a is a 5. So between the post and the pre, the operation that happens first will be the post, and then only the pre happens. When you use it as a individual statement, it doesn't matter whether it's a post or a pre, because anyway as a single statement it will be performed. As in by the way, post and the pre is only to increment or decrement a any variable exactly by 1. So if I had a plus plus, then this is equivalent to saying a is equal to a plus 1. So the equivalent expression would be a is equal to a plus 1. So a's value would have changed to a 6. Same case, whether it was a plus plus a, again it's a's value that's being changed. So when you're having a separate expression involving the incrementation of a, and whether it is a post or a pre, the operation is the same. It increments the value of a exactly by 1. If I had wanted to increment the a by some other value, so a is incremented by, let's say, a 5, then here is where the shorthand notation comes into use. When the same variable appears on either side of the assignment operator, the equivalent way of having the expression written will be a plus equals 5. So a's current value is incremented by 5. So such a augmented assignment operator or the arithmetic assignment operator is possible only when you have the same variable occurring on either side of the assignment operator. And this is not just a case with assignment operator arithmetic operators only. Such shorthand notations can be used with all the shift operators, the bitwise operators, and the rule is the same. The same variable has to appear on either side of the assignment operator. So a's value is incremented by 5 here. So when you get to display the value of 5, value of a, you will notice the a's value has been incremented by 5 after having commented these intermediate increment statements. So a, which was originally 5, has resulted in a's value to be a 10. Let's look at one example involving the comma operator. Actually, what I've shown here itself is a usage of a comma operator. Multiple variables being declared on the same line, and a and b also are being initialized as they are being declared. So this itself is a usage of the comma operator. Now let's assume c is going to be assigned with a statement like this: a going to be assigned with a new value 12, b to be assigned with a new value say 14, and c to be assigned with a new value a plus b. And at this point I try to display the final value of c. So let's see what this is going to show. It's showing a 12. So I actually had wanted a to take a new value 12, b to take a new value 14, and the changed values of a and b to be computed and shown as a 26. But what you need to understand, if you can recollect from the table of precedence of operators, the comma has got the least priority. So the assignment statement a assigned to 12 would have happened, and that 12 would have been assigned to c. So that operation would have happened first. So the rest of it is not going to be having any effect at all. So if I had wanted all of this to be happening, to be done, and finally the changed value of c to be the final value of c to be reflected, then I should have enclosed all of this in parenthesis. So now if you see the c's value, that will show a 12 plus a 14, that's a 26. One another example to show the comma operator. Here I've had an expression which says assigned to c. On the right hand side I have a plus plus comma a plus plus a comma a times 2. So I actually want a's value post incremented, pre incremented, the changed value of a times 2. But when I run the code, c is showing a value of 5. Again, post incrementation, this is use and then change. So it uses a's value as 5. So during the assignment, 5 has been assigned to c, and that's it. The rest of the statements are not going to be having an effect. So like I said, if I had wanted all the operations to have an effect, to be finally reflected as the final value of c, then I should have put in parenthesis. So the whole of the parenthesis would have happened, and finally the assignment to c would have happened. So here, so a's value is first used as a 5 and then changed to a 6. The 6 is pre-incremented to a 7, and the 7 into 2, 14 is what will be finally assigned to the variable c. So the comma operator, you must understand, has got the least priority in the table of operators. And if you have noticed, amongst the arithmetical operators, if you c does not have exponent operator. like in Python we have the double asterisk and so on. So the way we can do the exponentiation is probably we can include our header file math.h, and then in the header file we have this pow function. So let's say C is to take the value as a result of pow. The base is a and the exponent is b, so a raised to b can be computed using the pow function in the math.h. So if you look at the prototype of pow, prototype of any function will refer to three things: the name of the function, the number and data type of the arguments passed, and the data type of the value returned. So pow basically takes two values of type double and returns a value double. Because I've passed integers and I've used a format specifier %d to show the final answer, my answer is in terms of an integer. Supposing I had declared my variables to be of type float and used appropriate format specifier, then the pow function would have resulted in a corresponding floating point value. So that's a brief demonstration on operators on C. If you want more videos on C, please do subscribe.